Here's part 2 of our lecture on chapter 4.1. What we're now going to take a look at are what are called the electron shells. And it's really important to look at these electron shells because this is to know how atoms behave and also how atoms react. So we're going to be taking a look at what are called the electron shells. And we'll get to how they react in a couple more sections in the future. So an atom, well, one of the largest atoms that we have can have up to 118 electrons. And they're not just randomly going around the nucleus. They actually occur not in one giant swarm like a beehive, but they're very, very orderly. They have what are called their shells. So if you have your atom with the nucleus, so here's the nucleus, and again, the nucleus is on the inside. We're going to take a look at the first 3 shells. The first shell, the second shell, and then the third shell. The maximum number of electrons that you can put in the innermost shell that is next to the nucleus is going to be 2 electrons. The maximum that you can have in the second shell is 8 electrons. And for now, we're just going to say that the maximum that you can fit in the third shell is going to also be 8 electrons. These are important numbers to know. So what we have is, again, we have the first shell. We can fit 2 electrons. So here's the first shell here. And we have the second shell. The second shell has the ability to hold up to 8. And here is the third shell. It is also able to hold up to 8. It turns out that 2 and 8 are these magic numbers for how atoms react and how atoms behave. And we'll be getting to the organization of these electrons coming up in the future sections. So we took a look at the nucleus with the protons and the neutrons. We took a look at the electrons surrounding the nucleus, not in one giant swarm, but they actually occur in these different levels or different shells. And we'll talk about those shells a little bit later. Next thing we're going to be taking a look at, and our final thing for today in the lecture, is going to be the periodic table. So the periodic table. I'm going to be taking a look at one particular element in the periodic table, and it's going to be boron. I will give you and show you a periodic table for later, but if you look at online for boron, or even up at our ceiling in our room, it would look something like this. If you can draw a box, these are the tiles that occur on the ceiling. And in the middle of the tile for boron is a big capital B. This is the symbol for the element. As I mentioned, He is the symbol for helium. Boron has a number at the top of this tile, and it's number 5. This number is called the atomic number. Each element has its own number, and the reason why the periodic table is organized the way that it is because of this number, because this number is actually the atomic number, and it's equal to the number of the electrons, but it's also equal to the number of protons. So the atomic number is determined by how many protons does it have and how many electrons does it have. If you look at the bottom of the tile of boron, you'll notice a long number. It's 10.811. Okay, and this number represents the atomic mass. How much does this atom weigh? It weighs this. It's the atomic mass. And what I mean by the atomic mass is it is how much do the protons and neutrons weigh. The electrons that are in the shells are so tiny compared to our protons and the neutrons. So when it's really the atomic mass, what this really is the mass of the nucleus. How much does the nucleus weigh? Well, the atomic mass is the mass of the nucleus. What would you find on the inside of boron? What you would find is, well, the mass of the nucleus, what's on the inside of the nucleus? What two particles will you right now find on the inside of any nucleus? You will find protons, and you will also find neutrons. So this is boron. We already know that this number 5 represents the atomic number, which also represents the number of protons. So what we're going to do is we're going to plug in a 5 right here for the number of protons for boron. Now what you can do with this number, this is called the atomic mass, but if you round it, it has a different name. If you round this number to the nearest whole number, you will get what's called the mass number. So if you round 10.811, you use this right here, the tenths place, to round either up or down. It would round up, so we would actually have 11 for my mass number. Well, how many neutrons would I then have? Well, if my number of protons plus my neutrons, again, protons and neutrons, here's the mass of my nucleus, and this mass is equal to 11. I actually have boron is element number 5, atomic number 5. It has 5 protons, so I have 5, this is a little bit of algebra here, plus the neutrons equals 11. How do I solve for the number of neutrons here? Mathematically, I have to get rid of this number right here, and I would subtract by 5. And therefore, the neutrons in boron is going to be equal to 11 minus 5 is 6. Let's put this back up here. I have 5 protons and 6 neutrons, and they make my mass a rounded number of 11. But let's take a look at, we can do this for any one of the elements in the periodic table. Let's look at this formula. What did I do from both sides? I subtracted 5. What did I subtract from both sides, really? What does this 5 represent? It represents the number of protons. Let's rearrange this in terms of how to calculate for my neutrons. My number of neutrons is actually going to be equal to, well, I started with 11 and I subtracted 5. My 11 represents my mass number. So we have the mass number. And from this, we're going to subtract the 5, which represents the number of protons. This is the basic formula that you can use to calculate the number of neutrons for any type of atom. Okay, now what I want to do is let's take a look at an example for this. Let's figure out how many neutrons can be found in the element chlorine. Okay, if you can draw chlorine here. Here's chlorine. Chlorine is element number 17. Its mass is 35.453. Question is, how many neutrons does it have? Well, how many protons, how many electrons, how many neutrons does it have? We can do this. Number of protons, number of neutrons, and number of electrons. We can put their symbols like this. Okay? Based upon our previous rules, how many protons does it have? This here, again, is the atomic number, and it's the number of protons, and it's also the number of electrons. So I have 17 protons in this atom. How many electrons do I have? Well, protons are going to be equaling electrons, so I will have also 17. How do I calculate my neutrons? I have to take this number, which is my mass number, and round it. Is it going to round up, or is it going to round down? The mass number rounds to 35. Let's plug in this formula. My neutrons is going to be equal to the mass number minus the number of protons. So my neutrons is going to be equal to, my mass number is 35. My protons is 17. Therefore, I am going to have 18 neutrons in this atom. And we can check after all this mathematics. My 17 plus the 18 adds to this, which is the atomic mass or my rounded mass number. That concludes the lecture. If you can now go to the lab.